Looking at the Tacho generator on the x-axis of the Siemens Siplace F3. I've got the oscilloscope probes hooked up to the outputs. That's the red and the blue wire. The unshielded wire is indeed a ground, just coming over to the that'd be pin whatever it is, 1, yep. Then I've just got 2 pins into there, so I can hook the oscilloscope probes up to that. Oscilloscope is 1 volt per division, 200 milliseconds per division, so you can see the whole thing. It is just a tachogen, so it is generating a voltage. It's not generating any sort of pulsing that I can see. I need to zoom in on the time and see what it's coming out with. So when I move the head back and forth, because that's the x-axis along there, so towards and away from the oscilloscope, we should see something. I run this in single mode, so when I give this a good shove, hopefully it will, there we go, come back towards us, it triggers. So we've got a differential waveform, not really differential, inverse waveform, coming back and forth. If I just run this, you should be able to see it moving. Yeah, it's very slow because we've got 200 milliseconds per division, so it's more than a second of data there. So that's that direction. They go towards each other. I gotta get this trigger set right. So going towards, going away. Let's change this down to 100 milliseconds so we get a little bit more of an update rate. Go even faster. You can see. So, interesting little readout from that. If I run this really fast, let's go down to say 100 microseconds, 20 microseconds in single. Let's see what we can catch. Looks like not a lot of pulses going on there, so it is just a voltage readout there. It doesn't appear to be anything as far as a square wave coming off that tachogen. So it looks like we could have some interesting times with interfacing that with a motor controller.